stat class. Today we are going to review Chapter 3 together. Chapter 3, first thing of all, we are going to talk about scatter plot. Scatter plot, as we see, is a plot that have a y value and have an x value, and we put that in.
Which is called explainer variable and response variable.
Right, and it's also called independent variable and dependent variable. Lin-Jian, smart. Okay, now we need to examine the scatter plot. So Lin-Jian, there are 4 ways to examine the scatter plot: form, direction, strings, and outliers. Can we talk about that?
Okay, so you're the teacher. You need to tell me about that.
Okay. All right. To examine the scatter plot, we need 4 factors. Form, which is a linear relationships. So Lin-Jian, what's a linear relationships?
A linear relationship is that all the data in one scatter plot, when you draw a line, and it can it's the overall pattern is like a line, not a quadratic.
Yep, that's right. Okay, and then we'll talk about directions. Directions, we include positive association, which the line is going up like this one, and the negative association, which is going like this. And from positive and negative association, we can also say if the plot is strong or weak, positive or negative association. Lin-Jian.
Mr. Su, what's the relationship between R value and the positive or negative association and the strings?
We'll talk about that later, but I will tell you that R value, if it's a positive R value, it's going to be a positive relationship. If it's going to be a negative R value, it's going to be a negative relationship. And you have to know one thing, Lin-Jian, R can only be ranged from -1 to 1.
Oh, I see.
And we also consider sometimes outliers, which we are going to explain later, but it's just a general introduction. Outliers is like a plot. If the plot is here, it's definitely an outlier because it's too far away and cannot be explained by the line we set.
Right.
Okay, least square regression line. A regression line is a straight line that describes how response variables y change explainer variables x with the x change. And the least square regression line, like normal regression line, we represent them by y bar as the equation is always equal to, stop it. Hansen student, you are disturbing me. Lin-Jian, can you come here to write the formula of this?
Okay, alright. Okay, if you want to find the slope A, it is supposed to be A equals to R as Y as X. And S is the standard deviation. If you want to find the y-intercept, which is B, and B equals y bar minus A bar. And this is the value of this. So, this is how to calculate the A and B value of this family.
Very smart. Okay, please sit back.
Thank you.
And next time, if you don't bring the paper here, I would appreciate it. Okay.
If you don't bring the computer, I would appreciate it.
Okay, now the coefficient of determination, R squared. R squared is, of course, square of R. Explain that how many percent of the values can be explained by the linear regression line. So if it's R squared is 0.8%, we can say that 0.8% of value can be explained by the linear regression line. Okay, here's some facts about the linear regression lines. The distinction between the explanatory and response variables are essential in the regression. There is a close connection between the correlations and the slope of the least square regression line. Least square regression line always pass through y bars and x bars. The square of correlation, R squared, is a fraction of variations in the value of y that is explained by the least square regression line of
Mr.
y and
Su,
s. Okay.
What is residual?
Residual, that's what I'm going to talk next. Very smart, and okay, you already worked. Residual is the difference between observed value of the response variables and the value predicted by regression line. So it's like the differences between the predict value, which is a line on the y.
Can you show a graph?
Sure. Okay. Like this is least square regression line. And we have data here. The distance, the vertical distance between this is our residual.
Yes. Alright.
Okay. Something about residual. What's the differences between outliers and an influential point, Lin-Jian?
Outliers is individual points with larger residuals, but influential points are individual points which are extreme in the x direction. It's like it influences the y-intercept or the slope a lot.
Correct, and it's not necessarily going to have a large residual.
Yeah, but
Okay.
Outliers does not influence A or B a lot. Does not necessarily. Yeah.
Okay, seems we're going really fast, so I'm planning to give you guys a test tomorrow, but let's just do it now.
All right.
Okay, now my genius student Suman going to tell you how to use calculator to calculate LSRL.
Okay, so say you have some data in a scatter plot and you'd like to find the LSRL. What you do is you go to Stat, Calc, and then you press 4 to get the linear regression. And if you have your data in L1 and L2, you would do L1, comma, L2, comma, and you would go to Y1, like that. And press Enter, and it would give you the slope, the intercept, and R squared. And on top of that, it would give you the equation in function y1. And then when you press graph, you can see it.